Okay, these are the notes and examples for exercise 10.3, expansion of a plus x to the power of n. In the last lesson, we were looking at this expansion of 1 plus x to the power of n. Now, the binomial expansion for a plus x to the power of n and Pascal's triangle are related in the same way as the expansion for 1 plus x to the power of n. The same things are, for example, that the sum of the coefficients NCK, they would be all the different coefficients of a plus x to the n, is also 2 to the power of n. Another thing is that there are also n plus 1 terms in the expansion, in the binomial expansion of a plus x to the n. Now, if I write out the expansion of a plus x to the n, remember we start with the highest power of a to the power of n here, and again we start with NC0, that's the coefficient, a to the power of n. Then we go NC1, now we drop 1 power of n to a to the power of n plus 1 and bring in 1 power of x, okay? Then we've got NC2, so let's look at our coefficients, NC0, NC1, NC2, NC3. That will go all the way up to NCn, which I haven't done yet. Notice we've got the highest power of a to the n, then we drop down 1 power of a at a time, a to the n minus 1, a to the n minus 2, a to the n minus 3. Notice in the first term there is no power of x, however there is 1 power of x here, x squared, x cubed, okay? So we've got these first 1, 2, 3, 4 terms, so this fourth term is NC3, a to the n minus 3 x cubed. I'll put a general NCK term, so NCK a to the, notice it's NC3 a to the n minus 3 x cubed. This would be a to the n minus k, x to the power of k, plus, I'm going to do now the second last term and the last term. You don't have to do the second last term, but I'll just do it. NC to the n minus 1. Actually, it will get a bit messy doing that. I'm not going to do that second last one, because then we've got n minus 1. Actually, we can. NC n minus 1, I would have a to the n minus 1, which is, it would be, I'll just do it down here, it would be n minus 1, which is n minus n plus 1, it would be a to the 1, and we'd have x to the n minus 1. So this is NC to the NC n minus 1, a to the 1, x to the n minus 1. Remembering that as we go along, we drop 1 power of a, and the second last term will have only 1 power of a. And remember, the last term will have no powers of a, so we'll have NCn a to the 0, which is just nothing there, and x to the n. So look, I wrote that second last term in, but just be very careful with that. You don't have to when you're normally writing it out. You can just go the first 3 or 4, do an NCK term in the middle, go plus ... and then just add in the last term. You really don't have to put that second last one in. Okay, so that was for that a to the power of term there. Now, of course, this can also be written as a plus x to the n in choose notation, n choose 0, a to the n, plus n choose 1, a to the n minus 1 x, plus n choose 2, a to the n minus 2. Notice we're just dropping a power of a as we go along, x squared, plus n choose 3, a to the n minus 3 x cubed, plus, we'll just do this term, n choose k, a to the n minus k, x to the power of k, plus, I'm not going to do this n minus 1 term, I'm just going to do the last one, n choose n, x to the n. So that's also the general binomial expansion of a plus x to the power of n, written now this time using choose notation for our coefficients, okay? Now, one step further, we can also write the binomial expansion of a plus x to the n using sigma notation. Here's our general term. So actually we'll use this general term here, and then we'll do it in choose notation. So general term NCK a to the n minus k, x to the k. So of course it starts from k is 0, and then k is 1, 2, all the way up to k is n. So we start from k is 0 all the way up to k is n. So the binomial expansion can be written as sigma notation as follows. A plus x to the power of n is the sum from k is 0 to n of general term NCK a to the n minus k x to the power of k. N remember we can write that in choose notation, the sum from terms from k to 0 to n choose k, a to the n minus k, x to the power of k. So that's also a plus x to the power of n, written in sigma notation with the choose notation here. Now, just one thing to notice is that since n choose k, for example, you know, we know that, say, 6 choose 2 is the same as 6 choose 4 if we just look at something like this. So that means that n choose k is the same as n choose n minus k. nck is the same as nc to the n minus k. An example here is 6c2 equals 6c4. We've noticed that with the with Pascal's triangle, okay, and we've noticed that with our combination notation. Can write this also in choose notation, that n choose k equals n choose n minus k. This summation, so the binomial expansion for a plus x to the n, would also can also be written as the sum from k to 0 to n. Now, of n choose k, it doesn't matter which way I write it, or like that. Now, if I replace my k with n minus k, I get a to the n minus k, and if I replace this k with n minus k, I get x to the n minus k. So it's the same as the sum from k to 0 of n, actually I should write here n minus k, but it wouldn't matter if I wrote n minus k, a to the n minus n plus k, x to the n minus k. Sorry, that's off screen. So sum from k to 0 of n, choose n minus k, a to the k, n minus k. But that is exactly the same as sum from k equals 0 to n of n choose k, a to the k, x to the n minus k. But look, we just use this form here, where you've got n choose k, a to the n minus k, x to the k. But it is the same as this, okay? So that's just notice, something to notice, okay? But I don't want you to really learn that one. And also, the last thing is that the k plus 1th, oops, sorry, just get that off. So the last thing that we want to notice is that the k plus 1th term of a plus x to the power of n is nck, a to the n minus k, x to the k. So you can box that one in as well, okay? Just be careful you don't get confused with this, okay? Last thing is the k plus 1 term of a plus x to the n is nck, a to the n minus k, x to the k. Okay, now we'll look at some examples. Exercise 10.3, some examples. The first one is to write each product in sigma notation. So this is sum from k equals 0 up to 16, because we can clearly see here that n is 16. And then it would be 16 choose k, so I can either write 16ck, or I can just do the choose notation if I want to. Remember, it's a. Now, a in this case, actually, I'll just write what the general formula is. It's from k is 0 to n. Remember, it's it's n choose k, a to the n minus k, x to the k. That's our general formula. So just using that here, we've got 16 sigma from k equals 0 to 16. 16 choose k. A in this case is x to the power of 16 minus k. And here for our second term, we've actually got negative 2y, and that's negative 2y to the k. So that's, here's our general formula there, but this is our answer to the first one. 16, so sum from k 0 to 16, 16 choose k, or with combination notation, x to the 16 minus k, negative 2y to the k. Okay, question 2 is to expand this binomial product. Okay, remember, I can write out the choose notation, for example. So we've got, or our coefficients. We know our coefficients are going to be 1, 5, and then we have to work out what the others are. So we've got 5 choose 0, and then we've got our first term, highest power, 2 to the power of 5, plus 5 choose 1, 2 to the power of 4 times 3m to the power of 1 plus 5 choose 2, 2 to the power of 3 times 3m squared plus 5 choose 3, 2 to the power of 2, and we've got 3 m cubed, plus we've got 5 choose 4, 2 times 3m to the power of 4, plus the last term will be 5 choose 5, 3m to the power of 5. So now we work this all out. 5 choose 0 is 1. So we've got 1 times 2 to the power of 5 is 32. 5 choose 1 is 5. And we've got 2 to the power of 4 is 16, times 3 is 48, then we've got to times that by 5. 48 times 5 is 240, so we've got 240m. 5 choose 2 is 10, so we've got 10 times 8 times 3 squared is 9. So we've got 80 times 9, we've got 720, and we'll have m squared here. So remember, we've got to square the 3m, so we get 9m squared there times 8 times 10. Then we've got 5 choose 3, which is the same as 5 choose 2. So it's 10 times 4, which is 40 times 3 cubed is 27. Or we can do 27 times 10 is 270, then we times that by 4, and we get 1080. So I've got 1080 here, m cubed, plus here I've got 3 to the power of 4. Now that's 81 times 2 times 5. So it's 5 choose 4, remember, is the same as 5 choose 1, which is 5. 5 times 2 is 10. 10 times 81 is 810, and we've got m to the power of 4. Plus our last term, 5 choose 5 is just 1. Now we've got 3 to the power of 5, m to the power of 5, and 3 to the power of 5 is 243. And we've got 243 m to the power of 5. So that's that binomial product there. Sorry, just off the screen there. Okay. Next one is to expand this binomial product, 3 minus 2x to the power of 6. We're going to do the same thing again. So we've got 6 choose 0, 3 to the power of 6, plus we've got 6 choose 1, 3 to the power of 5 minus 2x to the power of 1, plus 6 choose 2, 3 to the power of 4, negative 2x all squared, plus 6 choose 3, 3 to the power of 3, negative 2x to the power of 3. Notice we're going down one power starting at the highest power of the first term with no powers of the second term, and then just introducing one additional power of the second term, plus 6 choose 4, 3 squared minus 2x to the power of 4. Then we keep going, plus 6 choose 5, 3 times minus 2x to the power of 5, plus 6 choose 6, we've got minus 2x to the power of 6. And now just doing those expansions, we've got, that will be 1 and 3 to the power of 6. You just have to work that out on your calculator. 3 to the power of 6 is 729. 6 choose 0, of course, is 1. Plus here we've got 3 to the power of 5. Now 3 to the power of 5 is 243 times negative 2 is negative 486 times 6, and you will get minus 2916, and we've got 1 power of x. Notice when you've got a binomial expansion with a minus, the first term's positive, the second one's negative, the third term will be positive again because you've got negative 2x squared. 6 choose 2 times 3 to the power of 4 times, now negative 2 squared is 4, so you can just go 6 choose 2 times 3 to the power of 4 times 4, and so your next coefficient will be 4,860, and you've got x squared. Then we've got minus, and just on your calculator, negative 2 cubed we know is negative 8, times 3 cubed is 27, times 6 choose 3. And for that you will get, just working it out, minus 4,320 x cubed. Then the next one will be plus. Negative 2 to the power of 4 is positive 16 times 9 times 6, choose 4. And when you do that, you will get plus 2160, and this is x to the power of 4. Then the next term will be a negative, so minus. Now 6 choose 5 is just 6, times 3 is 18, times negative 2 to the power of 5 is negative 32. So multiplying those, you get 576 x to the power of 5. 6 choose 6 is 1, negative 2 to the power of 6 is plus 64 x to the power of 6. So that is your expansion for 3 minus 2x all to the power of 6. That's your binomial expansion for that. Noticing again, you've got a positive, then a negative, a positive, negative, positive, negative, positive. Noticing to the power of 6, we've got 1, 2, 3, 4, 5, 6, 7. Again, no x term here. They increase by 1, the powers of x. And of course, yeah, same with, you'll just notice here with the pattern with the 3's going down as well. Okay, now question 3. In question 3 you have to write these as a binomial product and also find the expansion of those. So to write that as a binomial product, it will be x plus 2y, it must be x plus 2y to the power of 6, because this is of the form nck to the n minus k x to the k. So your a is x, your a is x, and your x, if it's a plus x to the n, is actually the 2y. So it's x plus 2y to the power of 6. And now writing the expansion of that, of course, you've got 6 choose 0, x to the power of 6, plus 6 choose 1, x to the power of 5, and then bring in your 2y, plus 6 choose 2, x to the power of 4. Then you've got 2y squared, making sure you use the brackets where you need to, plus 6 choose 3, x to the power of 3, 2y cubed, plus 6 choose 4, x squared, 2y to the power of 4, plus 6 choose 5, x times 2y to the power of 5, plus 6 choose 6, there's no x in this term, and we've just got 2y to the power of 6. And then just working these all out, we know that 6 choose 0 is 1, so we've just got x to the power of 6. 6 choose 1 is 6, so we've just got 6x5. Sorry, actually we've got 12, because 6 times the 2 here is 12, x to the power of 5, and then we've got y. Now, 6 choose 2, whatever that is, times 4. Oops, sorry. Let's bring that back. 6 choose 2 is 15, times 2 squared is 4. 15 times 4 is 60. Then we've got x to the power of 4, y squared. Plus 6 choose 3 is 20, I think. So we've got 20 times 8 is 160. So we've got plus 160. Notice we've got x cubed, y cubed. Plus 6 choose 4 is the same as 6 choose 2, which was 15. So we've got 15 times 2 to the power of 4, that's 15 times 16, which is 240. Then we've got x squared, y to the power of 4, plus 6 choose 5. Now that's just 6. 2 to the power of 5 is 32, so we've got 32 times 6, which is 192. So we've got plus 192 x times y to the power of 5, plus our last term, 6 choose 6 is just 1, times 2 to the power of 6, and that's 64 y to the power of 6. So that's the expansion of x plus 2y to the power of 6. Same with this one, just same thing again, but this is to the power of 7. So to write it in terms of a binomial product, our a is 2, so it would be 2 minus x, and our x term here is minus x to the power of 7. Okay, so that's writing that as a binomial product. And now as the expansion is 7 choose 1, 2 to the power of 7, plus 7 choose 2, 2 to the power of 6, negative x to the power of 1. And just keep going, 7 choose 3, 2 to the power of 5, negative x squared, plus 7 choose 4, 2 to the power of 4 negative x cubed plus 7 choose 5, 2 to the power of 3 negative x to the power of 4. Actually, I've missed one. This should be 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, 7 choose 4. Sorry about that. Plus 7 choose 5, 2 to the power of 2, negative x to the power of 5, plus 7 choose 6, 2 to the power of 1, negative x to the power of 6, and plus 7 choose 7, negative x to the power of 7. Okay, and then just working that all out, you've got, now we know 7 choose 0 is 1, so you've just got 2 to the power of 7. I think I had the video on for that particular question. We're just looking at the expansion of 3j. Okay, that's your a, and this is your x term, so it's 2 minus x to the power of 7. We've just started with 7 choose 0, 2 to the 7, or 7 choose 1, 2 to the 6, negative x to the 1, all the way down, and then we've just worked these all out. You can just do that, okay? Notice we're alternating between a positive term and a negative, a positive and a negative, positive, negative, positive, negative, and that's because we've got odd powers and then even powers of the negative. So every time there's an even power of the negative term, the whole thing becomes positive. When there's an odd power of the negative, you'll have the negative term there. The negative term will be here for the x cubed as well. Okay, and you're asked to write this as a binomial product without expanding. So we can see that the power is n plus 1, so it's going to be something to the power of n plus 1. Your a term is 3x and your x term is minus 2. So it looks like 3x minus 2 to the power of n plus 1, and this would just be the kth term. n plus 1k, 3x to the, you do this, n plus 1 minus k, and we can see that, and we've got negative 2 to the power of k. So, sorry, I should just move that all over, but it's 3x minus 2 in brackets to the power of n plus 1. And writing this one here, this is question 4j, writing this as a binomial product without expanding. Our power we can see is 2n. Okay, we're going from k is 0 up to 2n. Our first term is ax squared, and this is a positive second term, so it'll be 8x squared plus 7y all to the power of 2n, and that's just writing that as a binomial product. Okay, question 5, we're just expanding, doing two examples, C, 5c and 5j, we're just expanding these. So we've got 3 choose 0. Remember, this really is the expansion of 2 root 2 minus 3 cubed. So I'm doing the binomial expansion of 2 root 2 minus 3 cubed. That's just in sigma notation. So the first term will be 3 choose 0, or I'm writing it in combination notation, not choose notation. Then we've got 2 root 2, and if k is 0 first, you get 3 minus 0, or we do the highest power there. Then we've got, remember, no power, negative 3 to the 0, which is just 1, so we don't have any powers of negative 3 in the first term, plus 3 choose 1. We've got 2 root 2 squared, and then bring in 1 power of the negative 3, plus 3 choose 2. We've got 2 root 2 to the power of 1, negative 3 squared. And then our last term is plus 3 choose 3, no power of the 2 root 2, and we'll have negative 3 cubed. Okay, now just working these out, we know that 3 choose 0 is 1, so 2 root 2 cubed, 2 cubed is 8, and root 2 cubed is 2 root 2, because it's root 8, which is 2 root 2, plus this here, 3 choose 1 is 3, times 2 root 2 squared, 2 squared is 4, root 2 squared is 2, and we're still timesing it by the negative 3, so that's our second term, plus 3 choose 2 we know is 3 times, well, we've got 2 root 2 here, and negative 3 squared is 9, and 3 choose 3 is just 1, and negative 3 cubed is negative 27, so therefore we've got 16 root 2, So as I said, 16 root 2. Now 3 times 4 is 12. 12 times negative 6 is minus 72. Then we've got plus, we've got 3 times 2 is 6. 6 times 9 is 54 root 2. And then we've got minus 27. So combining like terms, we've got 16 root 2 plus 54 root 2, which is 70 root 2. And minus 72 minus 27 is minus 99. So that's the expansion of 2 root 2 minus 3 all cubed. Now the expansion of this here, remember we start with, I'll just do it down here, it's 3 choose 0, a over 3 cubed, plus 3 choose 1, a over 3 squared times negative b over 2, plus 3 choose 2, a over 3 times negative b on 2 squared, plus 3 choose 3, there's no a over 3, and you'll have negative b on 2 cubed. So we know 3 choose 0 is 1, a over 3 cubed is a cubed over 27. Now this next term will be negative, we know because we've got this term minus that one, but we can see, let's just do the numbers. We've got 3 times negative 1 on the numerator, which is minus 3. On the denominator, we've got 3 squared. Just be careful because this is a squared on 9 times negative b on 2. So on the numerator, we've got 3 times 1, a squared times negative b. Actually, I'm just going to do the whole numerator. I've got minus 3, a squared b. And on the denominator, I've got 3 squared is 9. Actually, I probably should expand it out first because you don't really want to make a mistake. So it's minus 3 times a squared over 9 times minus b on 2. That's better. Otherwise, you could, so that would be a plus. And there's my negative there. Plus 3 choose 2 is 3 times a over 3. And a negative b on 2 squared is plus b squared on 4. Plus 3 choose 3 is 1 times, and cubing this, I get negative b cubed over 8. So now I'm going to collect like terms. Just be really careful with this, or expand. A cubed over 27. Now I'm going to have minus. Now we can simplify this. We've got 3 on 18, which is 1/6. So we've got minus a squared b over 6. Then we've got plus, now the 3's here cancel, and I've got ab squared over 4. And here I've got minus b cubed on 8. Okay, and that's the answer to that. You really don't have to go common denominator. You'd end up with something quite large if you did that, a really large denominator. But just be careful. I'd probably work these out individually as I have done there. Okay, so that's 5J and C. Now for question 7. With this type of question, obviously you're just going to have to do the expansion of 2 minus the square root of 5 to the power of 4. You'll get a constant term and you'll get a third b root 5, and you'll just equate coefficients. So 2 minus root 5 to the power of 4 is just 4 choose 0, 2 to the power of 4, plus 4 choose 1, 2 to the power of 3 minus root 5 times minus root 5, plus 4 choose 2, 2 squared, negative root 5 squared, plus 4 choose 3, 2 times negative root 5 cubed, plus 4 choose 4, there's no 2 anymore, and you'll have negative root 5 to the power of 4. And we know that 4 choose 0 is 1, so we've got 1 times 2 to the power of 4 is 16, plus, now 4 choose 1 is 4 times 8 is 32 times negative root 5, so we get minus 32 root 5, plus we know that 4 choose 2 is 6, so we've got 6 times 4 is 24, negative root 5 squared is 5, so 24 times 5 is 120, so we've got plus 120. Now 4 choose 3 is just 4, times 2 is 8. 8 times negative root 5 cubed, now that is going to be 8 times 5, negative 5 root 5, so 8 times 5 is 40, negative 40 root 5, and then we've got a plus. Now 4 choose 4 is 1, negative root 5 to the power of 4 is positive, Root 5 times root 5 is 5, and doing that again, 5 times 5 is 25. So we end up with 120 plus 25 is 145, plus 16, 145 plus 16 is 161, and minus 32 root 5 minus 40 root 5 is minus 72 root 5. Now if that is equal to a plus b root 5, therefore we can say that a is 161 and b is just negative 72. Okay, now that's question 7. 12b, and it says by writing 0.99 as 1 minus 0.01, find 0.99 to the power of 4 to 4 decimal places. So we've got 0.99 to the power of 4 is equal to 1 minus 0.01 to the power of 4, which is, I'll just put it down here, 4 choose 0, 1 to the power of 4, plus 4 choose 1, 1 to the power of 3 times negative 0.01, plus 4 choose 2, 1 squared, negative 0.01 squared, plus 4 choose 3, 1 times negative 0.01 cubed, plus 4 choose 4, negative 0.01 to the power of 4. Now 4 choose 1 is 1 times 1 to the power of 4 is just 1. Now 4 choose 1 is 4, times 1 cubed is still 4. 4 times negative 0.01 will be minus 0.04. Plus, now 4 choose 2 is, so we've got 6 times 1 times negative 0.01 squared is going to be 0.0001, but times that by 6 and we get, it's positive as well, we get plus 0.0006. Okay, then we're going to have a negative term here. 1, 2, 3, 4, yep, that's correct. Okay, then 4 choose 3 we know is 4 times negative 0.01 cubed. We're going to get minus 0.123456. Okay, so negative 0.000004, and the last term is going to be positive, and 4 choose 4 we know is 1, so we're just going to get plus 0.004678, where we've got 7 zeros and a 1 on the end. And now to add those all up, calculator 1, take away 0.04 plus 0.0006 minus 0.000004, and plus, we need 7 zeros, 2, 3, 4, 5, 6, 7, and then a 1 on the end, and I get 0.96059601. Now, if you're rounding that to 4 decimal places, you would get 0.9606, okay? That's to 4 decimal places. And if you just do 0.99 on to the power of 4 on your calculator, you'll notice you actually get exactly the same answer as that, okay? So that's question 12b, okay? This is question 16d. Find the coefficient of the 5th term in the expansion of 2 minus 3n to the power of 9. Now we know that the k plus 1th term of a plus x to the power of n is nck a to the n minus k x to the k. So therefore, if we want the 5th term, we need, so for the 5th term, so if, in other words, k plus 1 equals 5, therefore we want k is 4. So we need k is 4. So therefore, just using this formula here, so the 5th term is 9c4, a to the, it would be 9 minus 4 is a to the 5, x to the 5. Now we need to use these numbers here. So it would be 9c4, a happens to be 2 to the power of 5, and x in this case happens to be negative 3n. Sorry, that should be a to the 5, x to the 4. So it's 9 choose 4, 2 to the power of 5, negative 3 to the power of 4, okay? Because this is a to the n minus k, so it would be 9 minus 4 is 5, x to the k, and k is 4, so you get x to the 4, or in this case minus 3n to the power of 4. Now, just working those out on your calculator. 9 choose 4 is 126, 3 to the power of 5, 2 to the power of 5, sorry, is 32, negative 3 to the power of 4 is 81, positive 81, and we've got n to the power of 4. So that equals 126 times 32 times 81, and we get 326,592 n to the power of 4. Now that's what the fifth term is, and so therefore the coefficient of the fifth term is 326,592. They want the coefficient, so that's the number in front of the n to the power of 4. So you don't include the n to the power of 4 in this. And also just notice when it's 9 choose 4, it's your second term, that's x to the power of 4 as well. And notice that the 5 plus the 4 add up to 9 as well. Plus 1th term in this expansion, remember the k plus 1th term, we've got the general formula. It's nck. Remember, we've got nck a to the n minus k times x to the power of n. That's the general formula for the k plus 1th term. So the k plus 1th term is the easiest one to do. So it will be 21 choose ck. A in this case is 3a. To the n minus k is 21 minus k, and times negative 2b to the k. So that is the k plus 1th term in that particular expansion. Now, for question 19c, if you're looking for the kth term, we're then going to have k minus 1 in this case. So this is question 19c, find the kth term in this. I'm just going to write it as the binomial product, and it will be something to the power of 8, and it will be 3 minus 2d to the power of 8. So the kth term will be 8 choose k minus 1, 3 to the power of 8 minus k minus 1, and we'll have minus 2d to the power of k minus 1. So that will be 8 c k minus 1, or 8 choose k minus 1 if you want to write it in choose notation. Now this will be 8 minus k plus 1, which will be 8 minus k plus 1 will be 3 to the power of 9 minus k, and here we'll just have negative 2d to the power of k minus 1. Okay, so just going to be careful with that. It's 8 minus k plus 1, so it's 8 plus 1 is 9. Okay, and now in question 20c, find the k minus 1th term in this expansion. Now the k minus 1th term, remember we're looking for a nc k minus 2. So it'll be k minus 1th term will be nc k minus 2 a to the n minus k minus 2 x to the k minus 2. So just using this particular question here, we've got 6c k minus 2 a to the 6 minus k minus 2, and in this case our x is 3a to the power of k minus 2. So we've got 6c k minus 2. Now 6 minus k plus 2 is a to the 8 minus k, and again we've got 3a to the power of k minus 2. So that's question 20c. And if I want to write it in choose notation, it would be 6 choose k minus 2, a to the 8 minus k, 3a to the power of k minus 2. Okay, from Cambridge exercise 5a, it's similar to question 22 in your exercise. It's question 10b from exercise 5a. Expand and simplify the following. 1 plus root 3 to the power of 5, take away 1 minus root 3 to the power of 5. So let's do the first expansion. It would be 5 choose 0, 1 to the power of 5 times root 3 in that one, plus 5 choose 1, 1 to the power of 4 root 3, plus 5 choose 2, 1 to the power of 3. I don't need to write the 1 to the power of 3. Then we go up root 2 squared, plus 5 choose 3, it would be root 3 cubed plus 5, choose 4, root 3 to the power of 4 plus 5, choose 5, root 3 to the power of 5. Now, take away in brackets, 5, choose 0, we've got 1 to the power of 5, plus 5, choose 1, we'd have 1 to the power of 4, and then we'd be timesing it by negative root 3 to the power of 1. Then we've got plus 5, choose 2, we'd have 1 to the power, I think, of 3, but then we'd have negative root 3 squared. Plus 5, choose 3, we'd have, I think, 1 squared, but negative root 3 cubed. Plus 5, choose 4, just not bothering about the 1, you've got negative root 3 to the power of 4, and then again plus 5, choose 5, negative root 3, that's a negative there, to the power of 5. So just looking at all that, we've got, so I'm just going to have to make this a bit bigger, not sure if you can see it very well now, I'll just have to move it across. 5, choose 0 is 1, now we've got 1 to the power of 5, which is 1, plus 5, choose 1 is 5, times 1 is 5, we've got 5 root 3. 5, choose 2, I think is 10. So 5, choose 2 is 10, 10 times 3 is 30, so we've got plus 30. 5, choose 3 is 10, and timesing it by 3 root 3, which is plus 30 root 3. 5, choose 4 is 5. Now root 3 to the power of 4 is 9, so it's 9 times 5 is 45. And 5, choose 5 is 1. Root 3 to the power of 5 is 9 root 5. Then we are taking away 5, choose 0, so we've got take away, so writing that here. 5, choose 0 is 1, times 1 to the power of 5 is take away 1. Then this will be a minus, this will be 5 root 3. And this will be a plus, so we've got plus 30 because it's 10 times 3 is 30. This will be a minus, so it'll be minus. Now this is 3 root 3 times 10, which is minus 30 root 3. Then we're going to get a plus again, so we're going to get 5 times 9 is 45. Then we're going to get a minus, so that was just that one. Then we're going to get minus 9 root 3. Sorry, that's not a 5, it's 3. Minus 9 root 3. Now remember, if we look here, we've got brackets. So it's going to be 1 take away 1. Then we've got 5 root 3 minus negative 5 root 3, which is 5 root 3 plus 5 root 3. So we've got 10 root 3. Then we've got 30 minus 30, but we've got 30 root 3 minus negative 30 root 3, which is 30 root 3 plus 30 root 3 is 60 root 3. We've got 45 minus 45 is 0. But we've got 9 root 3 minus negative 9 root 3, which is plus 18 root 3. And so we will get 10, now these are all like terms, and we get 70, 88. So we'll get 88 root 3 for that particular expansion. 1 plus root 3 to the power of 5 minus 1 minus root 3 to the power of 5. Now that is the end of this particular video, okay? I will set exercise. Some questions, and they will be based on exercise 10.3. Okay, so just check your email. Just be careful here, this is a 9 root 3 as well, just fix that. Okay, so it'll be exercise 10.3 for homework. I will let you know which questions to do in the email that I send. Thank you.